Stay safe, happy learning. Say no to threat of electricity for the first time every time. In this video, we shall discuss the cooling means for electric machines, especially hydrogen cooling. The capacity of a machine is largely dependent upon its cooling or how effectively it is being cooled. The cooling problem in electrical apparatus in general increases in difficulty with increasing size of the machine. The surface area from where the heat must be carried away increases roughly as the square of the dimensions, whereas the heat developed by the losses is roughly proportional to the volume and therefore increases roughly as cube of the dimensions. This problem is particularly serious one in large turbine generator. This is the blades of turbine generator, where economy, mechanical requirements, shipping and erection all demand compactness. Even in modern size of machines, that is above a few thousand kVA or a few MVA for generators, a cooled ventilation system is commonly used. Rather elaborate systems of cooling ducts must be provided to ensure that the cooling medium effectively removes the heat arising from the losses. For turbine generators, which is shown in this picture appearing on the screen, commonly used means of cooling is hydrogen as cooling medium in the totally enclosed ventilating system. See, it is totally enclosed. The generators and turbine is totally enclosed and ventilating system. The hydrogen has the properties that makes hydrogen ideal for cooling is that number one, its density is only about 7% of that of air at the same under the similar condition of temperature and pressure, and therefore windage and ventilating losses are much less. Second is its specific heat on an equal weight basis is about 14.5 times that of air. This means that the same temperature and pressure, hydrogen and air are about equally effective in their heat storing capacity per unit volume. But the heat transfer by forced convection between hot parts of the machine this means that for the same temperature and pressure, hydrogen and air are about equally effective in their heat storing capacity per unit volume. But the heat transfer by forced convection system, the hot parts of the machine and cooling gas is considerably greater with hydrogen than with air. I repeat, the heat transfer by forced convection between the hot parts of the machine, this is the hot part of the machine, to the cooling gas medium is considerably greater with hydrogen than in air. I repeat once again, the heat transfer by forced convection between the hot parts of the machine and cooling gas is considerably greater with hydrogen than with air. The life of insulation is naturally increased and maintenance expenses are decreased because of the absence of dirt, moisture and oxygen. Fourth is the fire hazard is minimized. A hydrogen air mixture will not explode if hydrogen content is above 70%. The result of the first two properties, that is the property of being 7 points of the density than air and 14.5 times higher specific heat than air under similar condition of temperature and pressure. These two properties makes the hydrogen under same operating conditions, the heat which must be dissipated is reduced and at the same time the ease with which it can be carried off is improved. I repeat, as discussed earlier, the property of being the density of hydrogen only 7.7% of that of air and its specific heat being 14.5 times more than that of air, it makes it for the same operating conditions, the heat which must be dissipated is reduced and at the same time the ease with which it can be carried off is improved. I mean to say, the result of the first two properties is that for the same operating conditions, under the similar condition of temperature and pressure, the heat which must be dissipated is reduced and at the same time the ease with which it can be carried off is improved when cooling medium is chosen hydrogen. That's all in this video. Thank you. Stay safe. Happy learning. Please like, comment and subscribe. Thank you. Thank you very much.